Okay, so we are going to teach you what is mohr circle. The basic idea is if we create a circle like this, we create a circle like this, and then we give a coordinate like the coordinate like this. The coordinate like this. Yeah. And at that time, we define. Maybe we can use white color. Yeah. And here we define this is the sigma x1. And we define the axis. Here is the tau x1 and y1. And that means we define a circle. So that means at any point here, maybe we write them. We define is for horizontal from here to here is we call this is the sigma x1. And similarly, this because the coordinate should be the coordinate. The coordinate here we say is first one is sigma x1, and the second one is sigma is tau. Is a tau x1 y1. This is the point. That's the coordinate. So in this case, so we will know the distance here. The distance should be equal to tau x1 and y1 for the distance here. Maybe we write down clearly. The tau x1 and the y1 here. So we will have two distance. From here is a sigma x1, and this is the tau x1 y1. And when we go back to this formulation, When you look into this formulation, it's a very easy to find a value because sigma x plus sigma y divided by 2 is looks like average stress. Average stress. Yes. So in this case, in the geometric is a mathematics, we will look. You see here, this is the center of the circle, and the distance from the original to this center should be equal to sigma x plus sigma y. divided by 2. So this should be the distance. The distance. And also this is the sigma average. Is the average stress because divided by 2. And when you minus, so this distance should be this distance should be equal to this distance, and we need to write down here. The distance is equal to sigma x1 minus the sigma average, like the sigma x plus sigma y divided by 2. Yeah. And again, this will exist. We call this is a radius. We call this a radius. So in this case, from the partition, you will look here. From the equation, so sigma x1 minus sigma x plus sigma y divided by 2, and the square and the plus tau x1 y1 square. This is the formulation. So if we can find a value of r is equal to this, if we can find a value of r is equal to this, equal to r squared, and then we can say this is a circle. If we can find r is equal to this one, and we can say this is a circle because this is a triangular. This is a triangular because here this is a triangular. Okay, maybe we can use yellow color because this is a triangular. So now we need to find is equal to r or not. But remember yesterday we have the formulation. When we try to find the sigma p, principal angle, we can find tangent to p is equal to this relationship. So in this case, you look, the r value is just equal to the square root of this value. So we are very lucky. Lucky is the r is equal to square root sigma x minus sigma y divided by 2, and the square and the plus tau xy square. So we are very, very lucky is when the square for this one, r square is just equal to this partition. Yeah. So that means this circle, that any point around the circle is just all the same as the formulation. So that is the idea is this is a similar. The circle, any point around the circle is similar to this formulation. So we call this is a mohr circle. So after that, you don't need to remember any formulation. You just know the position of the any point on the circle, and you will know the stress, because this stress, this is the formulation. We are calculate the stress, but now today, when you learn mohr circle, you don't need to remember the formulation. You just draw a circle, and you can get any value on the circle. The value is equal to the stress on any theta. So this is the basic idea of a mohr circle.